Hello guys, my name is Vihasu Hasbhat and I'm currently studying in Sri Venkateshwara College of Engineering. Today we're going to talk about understanding signal concepts and signal functions related to Unix systems. So this is a comprehensive analysis of signal concepts and functions in the Unix systems. So firstly, what are signal concepts in Unix systems? First is the definition of signals. So these are basically notifications sent between processes to indicate changes or events. There are different types of signals. This Unix system supports various signals, including interrupts, termination, and user-defined signals. Next is what are the uses of these signals? So they are commonly used for process control, error handling, and communication. And next is the importance of these signals. So this understanding signals is essential for efficient programming and system management in Unix. Next, we're going to look at the types of signals in Unix. The first is the standard signals overview. So standard signals have predefined functions like interpreting processes and terminating them. So that is the limit of those signals. Next is a signet. So signet is triggered by the keyboard to interrupt a running process, allowing for user control. Next is sigterm. Sigterm is a terminational signal, politely asking a process to terminate and clean up. Next is sigkill. This is a forceful signal that immediately terminates a process without any cleanup. Next is SIGUP. SIGUP notifies a process that the controlling terminal has been disconnected, often used for session management. Next is real-time signals overview. Real-time signals ranging from signument to sigmax provide higher priority of application-specific tasks. Next is higher priority again. So real-time signals are processed before standard signals, ensuring timely execution of critical tasks. Next is application-specific use. So real-time signals are tailored for specific applications, allowing for enhanced communication and control. Next, we're going to look at signal handling mechanisms that we have. The first is default actions for signals. So each signal has predefined default action, which can be altered by the process. Next is ignoring signals using sig underscore IGN. These processes can choose to ignore specific signals by using sig underscore IGN as constant. Next is custom signal handlers using signal function. So processes can define their own actions for signals using the signal function. Next is example of custom handler for SIGINT. So a common use case is to define a custom handler for SIGINT signal to manage interrupt events. Next, we're going to see what signal function is. So this basically is setting a custom handler, so allows the user to define a function that will execute upon receiving a certain or specific signal. Next is restoring default action. So this enables reverting to the default behavior for a signal after a custom handler has been set. Next is ignoring signals. This provides the option to completely disregard the specific signals by setting the handler to sig ignore. Next is an example for handling sigterm. So demonstrates how to use signal function to handle sigterm signals in practical scenarios. Next, we're going to look at the advanced signal handling with sig action function. So this gives a detailed control over signal handling. So SIG action allows for more precise control over how signals are handled, ensuring better management of signal delivery. Next is struct sigation fields. So the struct sigation contains fields that specify the signal handling behavior, including the signal mask and the signal handler. Next is the example using sigation to handle sig user 1. So an example of implementing sigation for handling the sig user 1 signal, showcasing a practical application. Next, we see blocking and unblocking signals. So understanding how to manage signal delivery is critical sections. So blocking signals using sigpromask. So this utilizes sigpromask function to block signals from being delivered. Next is syntax and usage. So proper syntax and context for using the sigpromask function is needed to effectively run a program. Next is blocking SIGINT during file operations. So this demonstrates how to block SIGINT to ensure file operations complete without interruptions. Next is unblocking signals and pending signals. Details on how to unblock signals and manage any signals that may have been pending. Next is signal sets and sig sets. So first is defining signal sets. So SIG sets serve to group signals, allowing for efficient management and operations. Next is functions like SIG empty set, SIG fill set, SIG data set, and SIG del set. These functions are vital for creating and manipulating signal sets within an application. Next is an example of creating and modifying a signal set. This demonstrates practical applications through an example of how to define and adjust sets in a code. Next is the use case for signal set. Signal sets are employed in various scenarios such as process management and signal handling mechanisms. Next, we are going to see how sending signals with kill and raise works. So first, using kill is to send signals to other processes. So it allows a process to send signals to other processes, facilitating inter-process communications. There's a syntax and example for it. So syntax for kill is kill with a PID and signal. That is the sender's ID and the signal. So example has also been given. So for termination process, we use 1, 2, 3, 4. Next is using raise to send signals to current processes. So this is to send a signal to calling process itself, allowing it to handle signals like second and sig term. So practical examples for terminating a process, signaling a child process, this is the basic example. So if it includes terminating a process with kill and signaling a child process to perform a specific action, then that is an example for the kill and raise signals. Next, we're going to see real-time signal processing. So characteristics of real-time signals ensure that prioritized delivery and can carry additional information with payload. Next is sending and receiving real-time signals. Processes can send and receive real-time signals, which allow for more efficient communication. Next is examples is SIGQ. So this function allows for sending real-time signals along with the payload to receive process. Next is difference from standard signals. So real-time signals differ from standard signals by providing a guarantee of order of delivery and ability to send more data payloads. Next, we're going to see the practical applications and case studies. The first practical application in system programming is the signals play a crucial role in managing system events and inter-process communication. In real-world case studies, we see that analyzing successful implementations of signal in various systems illustrates their importance. Next, we see in examples while using signals for graceful shutdown of a service that employing signals allows the service to terminate more smoothly, ensuring data integrity and security. Next is a summary of best practices. So adopting the best practices for signal handling can prevent system issues and improve reliability. Thank you, friends. Have a great day. Kindly do like the video and watch the entire part of it.